Welcome to The Hidden Layer, where we decode the future of AI. What if I told you there's a secret to giving an AI what is, for all intents and purposes, an infinite memory? Well, today we're diving into a paper that does just that. Let's get into it. So, we all know how incredible modern AI can be, right? You've seen it. You can ask it to write a beautiful, complex sonnet, and it'll spit out something that could honestly be from Shakespeare. But here's the crazy part. Take that same brilliant AI and give it a task that seems way simpler, like, hey, read this long book and tell me about the main character's journey. And it just breaks. It completely fails.
So what is going on here? Why does this happen? What is this invisible wall that even our most powerful AIs keep smashing into? More importantly, what's the secret to breaking through that wall for good?
Well, in the next few minutes, we are going to unpack all of it. We're going to explore a completely new way of thinking that shatters those old memory limits. You'll see how you can literally make an AI think like a programmer. And for all you engineers out there, we'll cover how you can use this to build way more powerful and, get this, verifiable AI agents. Oh, and you're definitely going to want to stick around, because I'll reveal a simple trick that can boost a small model's performance by over 28%. All right, so first things first, we have to really understand the problem. It's all about the AI's memory limit, or what researchers call hitting the context wall. And it's not just about running out of memory. No, it's way worse than that. There's this phenomenon called context rot. And it means that as you give an AI more and more information, it doesn't just get a little forgetful. Its entire ability to reason and get things right just rots away. And this chart, wow, it shows this perfectly. This is a top-tier model we're talking about, like a GPT-5. Now, on easy tasks, it's fine. But look what happens on a really complex task that requires it to compare a bunch of different things in a text. As the text gets longer, the performance doesn't just dip, it nosedives straight to zero. And look, this happens way before it even hits its technical memory limit. That is the wall. So, if just building a bigger memory, a bigger context window, isn't the answer, what is? Well, it turns out we need a completely different way of thinking about the problem, a total paradigm shift called the recursive solution. Let me give you an analogy. A standard AI model is like a person who has to rely purely on their short-term memory. You ask them to remember an entire library, it's just impossible, right? But a recursive language model, or RLM, is like giving that same person a computer and teaching them how to write little scripts to search the library's catalog. They don't have to remember everything. They just need to know how to find everything. It's a total game changer. And the researchers behind this had this one brilliant core idea. They said, stop trying to cram every piece of information into the AI's brain. Instead, treat all that information as just part of the outside world, part of an environment that the AI can interact with using code. Okay, now this is where it gets super cool. Look at this diagram. You see that huge prompt, that long book? It doesn't get fed directly into the main AI. Nope. Instead, it gets loaded into a kind of programming sandbox as a variable. From there, the main AI's job is to write code that slices up that huge text and then calls on smaller mini-me versions of itself to go work on each piece. It becomes a manager, not a memorizer. All right, I know what you might be thinking. This sounds incredible in theory, but how does it actually work? Let's pop the hood and get into the nuts and bolts of how you teach an AI to be a coder. It's basically a 5-step workflow. First, it accesses the data, but it just holds it at arm's length as a string variable. Second, it iterates by writing actual code, yep, like a Python loop, to chop that massive variable into smaller, manageable chunks. Third, it generates subanswers by calling a mini version of itself on each chunk. Fourth, it navigates by saving all those little answers into new variables. And finally, it executes one last piece of code to put it all together into the final response. Let's watch it in action. So check this out. The AI here is acting like a developer. It's not trying to read a giant document. Instead, it writes a little bit of Python code using what's called regex. Think of it like a super-powered Control-F to intelligently find and pull out only the most relevant pieces of information. And it doesn't stop there. Then it gets really efficient. It writes another piece of code, a loop, to go through that filtered information in nice, clean batches. And inside that loop, it makes those calls to its mini-me helpers, telling each one to analyze just one specific batch of data. And for the grand finale, it takes all the little answers it got back from its helpers, which are now just sitting there as variables, and it writes one last script to programmatically stitch them all together into a final coherent answer. And the key is,
this final output can be way, way longer and more complex than anything it could have created on its own.
So, okay, that's the how. But what about the why? What's the real payoff here? Well, it's about building a whole new generation of AI agents that are not only more powerful, but crucially, more verifiable. If you're an applied engineer, this is where you should probably lean in. First, verifiability. This is huge because the AI's thought process is literally just code. You can read it, you can audit it, you can debug it. It's not a black box anymore. Then there's scalability. It's just off the charts. It handles inputs that are gigantic. It also crushes complex tasks that regular models choke on. And it can even be way more efficient and cheaper because it only processes what it needs.
And you don't have to take my word for it. The proof is right here in the numbers. Look at this. On that complex reasoning task, the base GPT-5 scores less than 0.1%, a total catastrophic failure. But you take that exact same model and just wrap it in this recursive framework? Boom, the score jumps to 58%. That's not just an improvement. That is a resurrection.
And hey, remember that little secret I promised you at the beginning of this explainer? Well, here it is. By taking a small model, an 8 billion parameter model, and fine-tuning it on just 1,000 examples of this recursive process, its overall performance shot up by an average of 28.3%. That is an absolutely insane return on a tiny amount of training. So when you put it all together, the big takeaway is this. The next leap forward for AI isn't just about building a bigger brain with a bigger memory. It's about building a smarter brain. A brain that understands its own limits and knows how to use tools, how to write code, to solve problems it could never hold in its head all at once. Which leaves us with one last fascinating question to think about. As we build this future, are we creating AI agents that aren't just thinkers, but are, at their very core, coders? Let that one sink in. Thanks for watching The Hidden Layer.